So let me erase this part and let us start from the beginning. So we already talked
Last
about this.
class you were talking about linear equation.
Yeah, but as you said that you want one-to-one classes, so you will not be joining any batches. So in that batch, I was teaching the linear equation in two variables, right? So, but then you said that you want one-to-one classes, right? So then we can start from the beginning, right? We don't need to bother about the other batches,
Okay.
right? Yeah. So let us start with polynomial, and then we will go to this linear equation. Okay.
Okay.
Yeah. So let me. So we talked about this. We talked about this degree of the polynomial and the kinds of the polynomial in the previous class, right?
Yes.
So we talked about that if we have one term, so that is called what?
Monomial.
Monomial, right? And if we have two terms, so then this is called binomial, right? And then if we have three terms, so this is called trinomial and so on, right? So this is based on the number of terms. And we learned that the polynomial have two basic conditions. So if a polynomial has, or if the terms have, right? So a
The degree
polynomial
cannot
can't,
be have
yeah,
the degree
a
can't
polynomial,
be
yeah, a polynomial can't have negative powers, right? And then we understood that a polynomial can't have fractional powers,
yes.
right? So these part we understood in the previous classes. And then we divided the polynomials on the basis of the degree of the polynomial. So we defined that degree of the
Linear
polynomial,
linear
yeah,
linear quadratic cubic.
yeah. So degree of the polynomial is highest power on the variable. So I'm just repeating what we have studied in the previous class. So highest power on the variable, and then we studied that if we have one degree, so this is called a linear polynomial. And then if we have 2 degree, so this is called quadratic, as you said. And then if we have 3 degree, so this is called a cubic polynomial, right? Right, Rifa? So this part we did in the previous class. Is that correct, Rifa? Yes, am I audible? So
Hello, can you hear me?
yeah. Now I can hear you. Yeah. So maybe you are facing some internet issues.
Yeah.
So yeah. Yeah. Then we have this zeros of the polynomial, right? Zeros of the polynomial. So what are the zeros of the polynomial? So let's say if I have the polynomial which is represented by px, and if I equate it to 0, right? So this equation would give me the value of x, for which my px is 0, right?
Yes.
So these x will be called the zeros of the polynomial. Right. So let's say that if I have px equals to, let's say, x squared plus 2x plus 3, right? And let's say that if I put p equals to minus 2, I don't know whether this is correct or not. Let's assume that if I put p minus 2 equals to 0, this gives me 0. So this minus 2 would be one of the zeros of this polynomial.
We can put any number in the place of x, right?
No, we cannot. Right, we cannot. So then I have to, yeah, I just guessed that, let's say, minus 2. So we have to put only that value for which this is 0. Let's say that value is alpha, and that value is beta. So for these two values, right, because I have degree equals to how much? Yeah, what is the degree of this polynomial?
2.
2. So I will have two zeros, right? So 2x value would give me px equals to 0, right?
Yes.
Understood? Yeah. So for whatever value of x, if I get px equals to 0, so those are the zeros. And this zeros of the polynomial is related with this degree of the polynomial, right? So the number of the zeros of the polynomial is equal to the degree of the polynomial.
So if we have a cubic polynomial, like the highest degree is 3, so it means they have 3 zeros.
Yeah, 3 zeros. That would be alpha, beta, gamma, right? So yeah, you are absolutely correct. So whatever the degree of the polynomial, so that would be the number of the zero that I would get. Okay.
Yes.
Yeah. So and now you have two. So then we get two kinds of solution of solution of the polynomial. Right. One is this graphical, and the other one is this algebraic. So we can find the zeros of the polynomial in two ways, right? Graphical or algebraic. So let us understand about the graphical solution of the zeros of the polynomial. Okay. So let me ask you this question first, that we have this graph, right? So in this axis we have this x coordinate, and in this axis we have y coordinate, right? So at this line, what is the value of y? On this line, what is the value of y?
Value of y.
Yeah, on this line, on the x-axis, what is the value of y?
Positive.
Positive. So let me write the numbers, then it would become more clear to you. So the value of x, let's say this is 1, 2, 3, 4, 5, and so on. And this is how much? This is -1, -2, -3, -4, -5. So this is the value of x on this line, right? And the
Yeah.
value of y in here is 1, 2, 3, 4, and 5, and so on. And in here, -1, -2, -3, -4, -5, and -6, and so on, right? So if I want to represent 2, 3 points, so this will lie in This is 2 and this is 3. So this is 2 comma 3 point, right?
Yes.
And if I want to denote, let's say 5 comma minus 6. So this would be in here, right? But what is the coordinate of this point? Can you tell me?
Coordinate.
Yeah, coordinate of this point. So this you learned in the graph, right? So you have what, how do you represent the coordinate? By x comma y,
Yeah.
right? So x value is minus 5 here. What is the value of y here?
0.
0, right? And at this point, 3, 0. And at this point, 4 comma 0. And let's say whatever, let's say this is 8, so 8 comma 0. So as you can see that what is the value of y on this x-axis?
0.
0. So the graphical solution of the zeros of the polynomial says that, let's say that if you, so let's say this is x and this is the graph of px. And px is varying like this, right? So what is the value of px? This is y. What is the value of px at this point? Yeah, what is the value of px at this point? Just take the analogy from, yeah,
5.
no. So at this line, y was how much? Now your y is px. So at this point, y was how much?
Are you asking the value of y or x?
Yeah, value of y, value of y.
It is 1.
So how much upward we have moved in this x-axis? 0, right?
Yeah.
So the value of y, which is px, would be 0 here.
Okay.
Is that clear? Just take the analogy from here. So at this point, on the x-axis, the value of y was 0 everywhere. Right, on this axis, value of y was how much? 0. Is this part clear? So similarly, yeah, so similarly, in this case, this is px and this is x. So px is varying like this, right? And at this point, value of px would be how much? 0. So is this part clear?
But shouldn't we count the points accordingly? Like
Yeah,
in the textbook, there is an exercise. So in that, they're trying to find the value of p of x in that number. So we count the number of points which is there. So that's the number of zeros which is there in the x-axis and
yeah,
y-axis.
yeah. So why? Yeah, that is the point that I want to make, that why we are calling these points as the zeros. Why we are calling these points at the 0? Because what is 0 here? Yeah. How do we define a 0 of the polynomial?
The degree of it.
So for the zeros of the polynomial, my px equals to 0. This is the criteria for the zeros of the polynomial, right?
Yeah.
So as I was discussing that value, so in y-axis, what do we have? Px, right?
Yes.
And at x-axis, on the x-axis, the value of y is 0, right? So this
Yes.
means that value of my px is 0 at this point, value of my px is 0 at this point, value of my px is 0 at this point, and so on. right? So at this 1, 2, 3, 4, and fifth point, so at these 5 points, my value of px is 0. So that is why we are calling it at the zeros of the point. Understood?
Okay. Yes,
So
understood.
yeah, so that is why we are saying that we have how many number of zeros? 1, 2, 3, 4, 5.
5.
So this is why we say that whatever the number of the points that the graph cuts the x-axis, right? So at the x-axis, our px becomes 0. So whatever the numbers that we get, so that would be called the zeros of the polynomial. Understood?
Yes, understood.
Yeah. So this is what is your first exercise of this second chapter. Okay.
Okay.
So now let us do some very difficult questions. Okay. So yeah. Okay. So this is about this first exercise. Right. So as you were telling that in the exercise, you learned that whatever the number of x's that these points were cutting, so that gives the number of the zero. Yeah. So you tell me for this graph, what is the number of the zeros? Yeah. For this graph.
It is 1.
So how many points does it cuts the x-axis? Yeah.
1.
Or even does it cuts the x-axis, not the y. This is y-axis. This is x-axis.
Okay.
So
No,
does this graph?
it doesn't cut
It
the
is not
x-axis.
cutting the x.
So it's 0.
Yeah. So it is not. So the number of zeros would be how much?
0.
Yeah, zeros, right? And for this graph, so this is the graph.
Cutting. So it will be 1 0.
1 zeros, right? Yeah, absolutely right. And for this one,
3 zeros.
3 zeros, right? So 3 zeros, and let us quickly go to this. So how many zeros?
Then the fourth one, 2 zeros.
Okay,
4 zeros.
4 zeros.
Um, 2 zeros.
So
This is
how many points does it cut the x-axis? So 1, 2, 3,
3
right?
zeros.
So 3 zeros. So this was about this first exercise of this polynomial chapter. Do you have any doubt in this first exercise?
No.
Okay.
We can ask in the y-axis also.
Yeah, y-axis doesn't give you the zeros of the polynomial, right? On the y-axis, px, so px has some value. It is not 0, right?
Yes.
Yeah, so we don't count the points which it cuts on the y-axis. So this is
Oh,
not the 0,
yeah.
right? This is not the 0.
So I am asking, like, here they are
Yeah,
telling find the number of zeros in P of X. So they can tell find the number of zeros in
yeah.
P of Y.
Okay, yeah. Okay, so if, yeah. So if you have the variable, so if you write, yeah. So now let us understand about this function. So you have this x and then you have this fx, right? So this is the independent variable, right? And then this fx is the function of x, which is dependent upon this x. So this is the dependent variable. And if you're writing the independent variable as y, and then if you are drawing this fy, right? So then you can say that whatever points it cuts the y-axis. So this is your y and this is your fy. Okay. So at this line, your fy becomes 0. So then it will be the number of the zeros. Understood?
Yes, understood.
But this graph is only about this px, not py. Py is not given, right?
Yes.
Yeah. So let's say that let us make the simpler diagram. So if this would have been y, and then if it would have been py, and then if this would have been your graph, so then you can tell that this is the number of the zeros, right? But not in this case. Clear?
Yes.
Okay, now the second exercise is about the zeros and the coefficient. So let us understand the concept first. Okay, so we have, yeah. So first, let's say that we have a degree 2 polynomial. So what is that polynomial? Yeah.
The quadratic one.
So I have a quadratic polynomial, right? And if I equate the quadratic polynomial to 0, so what do I have? So this is called what?
Zeros of the point.
Now, so I have a quadratic polynomial, which is, let's say, which is px. And if I equate it to 0, so this will be called a, obviously these x would be the zeros of the polynomial, but
Quadratic equation.
yeah, so this is called the, yes, absolutely right. So this is called the quadratic equation. And we have a general form of the quadratic equation, right? So
Ax square plus b.
yeah, yes, absolutely right. So we have the general form of the quadratic equation, and this is represented by ax square plus bx plus c equals to 0. Okay, so where these a, b, c are the coefficient and the constant, right?
Mm.
And then let's say that how many zeros would be there for this equation, quadratic equation? How many zeros would be there?
2 zeros.
2 zeros. So let's say that they are alpha and beta. Right. So in the form of the alpha and beta, I can write the quadratic equation as, how do I write the quadratic equation in the form of alpha and beta? Do you remember?
Yeah.
Yeah. So we can,
Alpha, the sum of the zeros is alpha plus beta equal to minus b by a,
no,
and
not
for
that
the
one.
formula, okay, x square minus alpha plus beta into x plus alpha beta.
Yeah, this. So this is how we represent the quadratic equation in the form of the zeros, right? So
Yes.
let's say that this is one equation, this is second equation. So this is the same equation of the quadratic equation. So this should be the same, right? These are the same equation, but different way, in a different way, right?
Yes.
Yeah. So let me ask you this question that you have this ax square plus bx plus c, right? And you have this x square minus, so the coefficient of x square is 1 here, right?
Yeah.
And the coefficient of x square is a here. So how can we make the coefficient of x square as 1? Yeah.
Can you repeat?
Yeah. So you see that the coefficient of x square is 1 here, right?
Yeah.
And the coefficient of x square is a here, right? So I
Yes.
am asking that how can I make the coefficient of x square as 1 here? How can I make that? Yes.
You can put the value of x, like you can.
Hmm? We don't, yeah, so we know that value of x is alpha and beta, but I'm asking that I want to make the coefficient of x square as 1, right? So how can I do that? Let's say if I want to make it 1, so I divide it by 8. Is that possible?
Can we divide by 8?
Yes, Rifa. Yeah, can we divide it by 8? Yeah. So if we are
Mm.
dividing in one term, so we have to do it in all the terms, right?
Yeah.
So dividing equation 1 with a. Right, so this would be ax square by a plus bx by a plus c by a equals to 0 by a. Right, so this would give me 1, and this would become how much? So this would become x square plus b by ax plus c by a, and 0 by a is how much? Yes, 0 by a is how much?
0.
0, right? So these all equations are equal. 1, 2, and this is the third equation. These are the same quadratic equation in different way, right?
Yes.
So if I compare this third equation with this second equation, if I compare the coefficients, so coefficient should be the same, right? Because these are the same quadratic equation. So the coefficient should
But
be the same.
the second
So the
equation
coefficient of,
uh, the second equation we
yeah,
use it when we have to make a quadratic equation, right?
yeah. So yeah, so this is a quadratic equation, right? Right,
Yeah.
and this is the same quadratic equation. This is also a quadratic equation, right? So we
So
can
you're saying we can use
compare
both.
these.
So you're saying we can use both of them for like for making the quadratic formula, both the equation.
Yeah. Obviously, because both are the same quadratic equation that represent. So both are represented in a different way, but they are the same quadratic equation. That's what I am telling, right?
Okay.
Hmm? Yeah. So if you compare the second with the third, right? If you compare the second with the third, so the coefficient of x square is 1, right? So what is the coefficient of the x? So
1.
coefficient, yeah, now x, coefficient of x. Coefficient of x in equation 1 should be equal to coefficient of x in equation. This is all third. So this is second and this is third. Right. So what is the coefficient of x in equation second?
1.
Yes, Rifa.
X. Okay. Alpha plus
Coefficient
beta.
of x minus alpha plus beta, right? And what is the coefficient of x in equation 2, third?
B by A.
B by, right? So if I take minus in this side, so this would become alpha plus beta equals to minus b by a. So this gives me the relationship between the zeros and the coefficient. And it says that sum of the zeros is equal to minus coefficient of x divided by coefficient of x square. Is that part clear?
Yes.
Okay.
But
So this is the
in the
first relation.
exam, This is the
And
derivation of the sum of
yeah,
the zeros.
yeah, this is how
In
we
the exam,
derive,
they will
how
ask
do
the
we get the sum
derivation,
of
right?
the zero. Yeah, just for the sake of the knowledge, right? So how do you get, don't you get puzzled that how do we get this sum of the zeros as minus b by a? Don't you have that question? Ah,
Yeah, I guess. Because
yeah.
in
Should I
for
write
us,
only the
we
formula?
did for us we just learned it by heart.
Oh, yeah. So, okay. So then you accept that this is it. This is there. So we just accept that these are the value that we get, right?
Yes.
So are you not curious enough that how do we get? Okay, so then I will directly, okay. So what I will do is that I will directly write this formula. Okay.
Okay.
So yeah, so then we have this product of the roots. So we have the product of the roots would be C by A. Okay, so the sum of the zeros is minus B by A, and product of the zeros is C by A. Is that clear?
Yes, it is.
Yes. Okay, so now we have this cubic equation, right? So in the second exercise, we have two kinds of polynomial or equation. One is this quadratic equation, and the second one is this cubic equation. So let us understand about this relationship between the zeros in the cubic equation. So what would be the general form
But
of a cubic equation?
ax cube plus bx squared
Yeah,
plus cx plus d.
yeah. What was that? What was that? But do you have any doubt, question, or query?
No, I was in my class, like in my school, they didn't teach us the questions on the cubic equations, cubic polynomial, only
Yeah,
quadratic
yeah. There was
polynomial questions.
yeah, yeah. There was not any question based on this cubic equation, but if you see the rationalized syllabus, so if you see this rationalized syllabus, then you will find out that it is there. So you see, this is there, right? And you see this in the example. In the example, it is there, right?
Yeah.
So yeah, so they can. So you see that this is the revised syllabus, so they can ask about this cubic equation. So that's why I'm telling. So if they didn't teach, so then we can skip this. Okay.
Okay.
So then
But it's
we can
written
skip.
not from examination point of view.
Okay. So let's skip that. Okay. So do we have? Yeah. So yeah, we have a star. So this is not from the exam. So let us skip that. Okay. Let us skip that. Now, so there's only two concepts are there in this polynomial chapter. One is that what is the degree of the polynomial, then what is the zeros of the polynomial, and then lastly you have this, what is the relationship between the zeros and the
And the
coefficient
coefficient.
of the quadratic equation. So only the quadratic equation that you have. But you see that the question is not from the examination point of view, right? But do we have a star on this also? You can check that any, let us look at, do you think, check. Okay, so some of the zeros. So there was not any star on this part, right? So, okay, but If this has not been done in your school, so we can skip that. Right. Okay, so let us do this first problem. So what is the degree of this polynomial?
2.
2, right? So this is a quadratic polynomial, right? And if you want to solve the zeros of the polynomial, so we have to equate it with, what? 0, right?
Yeah.
So x square minus 2x minus 8 is 0. So this is a quadratic equation, right?
Yes.
And what is the value of a, b, and c?
A is x, which is nothing but 1, and b is 2x
B is,
minus 2x.
so we have to take no x. So what is b? So let us compare. We have to first compare this with this general form.
We have to do middle term splitting, right?
Yeah, so solution part comes later. We have to first identify what is a, b, and c. So you can see that the coefficient of x square is b, and coefficient of x is b, not minus 2x. So the coefficient of x is how much?
2 minus 2.
Minus 2, right? So a would be 1, as you said, b would be
Minus 2.
minus 2, not 2x, right? And c would be how much?
Minus 8.
Minus 8. So these are the values of the coefficient and constant. And this part is clear. Okay. Now we have to find what is alpha and what is beta. Right. Understood?
Yes, understood.
Yeah. So to solve this quadratic equation, we have to find the solution of quadratic equation, right? And there are three methods. One is this middle term splitting. Second one is this completing the square. And the third one is this quadratic formula. So from the point of this second exercise, only this one is needed. So this we will discuss in the quadratic equation chapter. This is not in the syllabus, and this we will discuss in the quadratic equation chapter. Okay.
Okay.
Yeah. So only so we will use this middle term splitting method only in the quadratic equation chapter. So what is this middle term splitting method? Right. So you have three terms: x square minus 2x minus 8 equals to 0. Three terms, right? And what is the middle term?
Middle term is minus 2.
Minus 2x. So this is the middle term. And in the middle term splitting method, we have to split this term. Right. But
So the factors of 8 will be
yeah,
2 4s
yeah.
are 8. So 4 minus 2 gives us 2. So we can choose those two numbers.
Okay, yeah. So you already, so this is good that you already know the criteria of the middle term splitting. So we have to follow some criteria to use this middle term splitting. So as you said, first we have to take the product of A and C, right, which is this 8. And then we have to take the factor, right? And then we have to choose combination which gives B. So these are the criteria that we follow to do this, to use this middle term splitting. So as you said, we have to take the factor of 8, right? So factor of 8 would be 2,
2, 4, 5.
4, 2, 2. So this is 2 into 2 into 2. This is 8. So what combination? So you already have told me about the combination. So that would be 2 and 4, right? 2 and 4 gives me 8. But what would be the sign of 2 and 4?
Minus.
Which one is positive? Which one is negative?
Minus.
Yeah, which one? 2 or 4? Which one
2.
is minus?
4 minus
2. So if I take, yeah.
2, 2.
So if I take this as minus, so this is minus 2 and this is 4. So the product would give me minus 8. Right, so this is there. But what about the addition? So if I add, this would give me what? 2, right? So, but I have minus 2. So what should I take?
Should take
Yeah,
this one. 2.
minus 4 and plus 2, right?
Yeah.
So minus 4 plus 2 would give me minus 2, right?
Yes.
So the factors would be, yeah, so the factors would be x squared minus 4x plus 2x minus 8, right?
Yeah,
So
now we can take
this would
x
give me
outside.
x, yeah,
Then
x common, so this would give me x minus 4. And then in here we
Yeah.
can take 2 common, so this would give me,
X minus 4.
right? So again, I have this, we
X
have these 2
plus-
terms. And x minus 4, yeah, x minus 4 is common. So this would give me x plus 2. Right. So I have 2 factors. 2 factors meaning 2 roots. So I can take this in the other side. So this would be 0. So one would be x minus 4 equals to 0. The other would be x plus 2 equals to 0. So this would give me x equals to 4. And this would give me x equals to minus 2. So my alpha is, how much? Alpha is 4 and beta is minus 2. Right.
Yes.
And A is 1, B is minus 2, and C is minus 8. Right. Right, Rifa.
Yes, correct.
So what
Then
would
we
be
have to verify.
alpha?
So alpha plus beta equal to minus b by a. So it's going to be
Yeah,
minus
so,
2 by 1. And
yeah,
alpha
so
into
minus
beta
2
equal to
plus,
c by a, which is minus 8
yeah,
by 1.
yeah. So alpha plus beta would be 4 and plus of minus 2. Right. So this is 4 minus 2, which is 2. Right, Rifa?
Yes.
This is the sum of the zeros. And what is the b by a that I get? Minus b by a. Minus b by a is minus of
Minus
minus 2.
minus 2 by 1.
So this gives me 2. So we can compare these two and say that alpha plus beta is minus b by a. And so this is how we verify that sum of the zeros is minus b by a. Right.
Yes.
And what about this product of the zeros? So alpha into beta would be how much? 4 into minus 2. Right. So this would be minus 8. And C by A would be how much?
Minus 2 by
Minus
1.
8 Minus 8 by 1, right? Minus 8
Sorry,
by 1, right?
3 by A, right? Yeah, it's 8. Yeah.
So minus 8 by 1, which means that minus 8. So if we compare this and this, so we can see that product of the zeros is C by. So you write QED, right? So what is the meaning of this QED? Do you know?
No,
Yeah.
no, I think so.
Yeah. So one simple meaning is that quite easily done. And the actual meaning is called error demonstrator. So this is a Latin word. And whenever we move the left hand side to the right hand side, so we can write QED, right? Okay, so you please note down this problem. Please note down this problem. So I will start with this second chapter and then we will continuously do this third, fourth, and so on chapters. Which chapter is being done in your school, Rifa?
In my school, they finished quadratic equations. So after this, you can do quadratic equation because even I'm doing that.
Okay, so can we not do this linear equation and then quadratic equation? Or you want me to just go to this quadratic equation?
Or you can go with quadratic.
Whatever. Yeah, okay, so let's in the next class or whenever we finish this exercise, so then we can go to this quadratic equation. Okay,
Um, when is the next math class? In a week, how many classes we have?
so in a week there will be 3 classes.
Maths,
Okay,
3 maths.
yeah, maths. Yeah.
Okay. So
Okay,
no, I think
so
I'm
just